So good morning, everyone. So last lecture we talked about was we looked at the industry for higher education. We looked at what were some of the systematic differences between public schools and private schools, between these schools and community colleges as well. And what we're going to do today is we're going to talk about, is there heterogeneity in the returns to schooling based on whether school is public or private versus money, and what has been done in the economics literature to try to pin down this question. Okay, so that's kind of the big framework for what we're going to do today. And so we're going to start to dig a little bit more deeply into the papers. I'm going to hand out some printouts from some of the papers as well that we'll cover today in class. Did any of you have an opportunity to look at the paper that Shannon sent out yesterday? Okay. So what was the paper about?
Well, returns to school based on the goal.
And what was the main finding of the paper? Okay, that's fine. Does anybody know or remember the main finding of the paper, Mike?
That there were large positive returns to more prestigious schools unless you try to control for unobservable characteristics of the students.
Exactly. And what was the way in which the authors controlled for unobserved characteristics?
By average SAT score of all the schools they applied to, which I thought was weird.
Okay.
I don't really understand how that was a good variable. Like I read the explanation, but it was odd.
Okay. Well, we'll get into that a little bit more as we go through the. Okay. So what I'm going to do is I'm going to hand out two things. So just hold on to these guys as we go through the lecture. And then we'll come to that.
That's what we were all thinking, right?
My homework. Can I bring tea after class or either?
Yeah, and also thank you very much for your comments too. Like, they were very helpful, the feedback that you gave. And I'm going to make sure that we tether whatever we do in the class to kind of like the big overall picture for the course. And then also, especially when we do any kind of proof or derivation, that we're explicit in terms of understanding why it is that we do it. Okay. So, we can title this heterogeneity. So far, we've used the Mincer equation, Mincer-Onions equation. To estimate the returns to school. Who can remember what the Mincer equation looks like? What does it look like? Oh, can you speak up?
Long way equals way to not alpha. Gamma. Years of schooling. Used experience at one point.
Right, so we can put in like some, these are going to be our controls, and then what? Error. Does everybody remember this? This is what the Mincer equation is. Okay. And so this was telling us the relationship between years of schooling and WI. Who can remember what the interpretation on gamma is?
It's the change between very change in SI is change between low WI. It's like the, and I know it represents the
Yeah, exactly. So for a 1 additional year of schooling, this is the percentage change in wages, right? Okay. And so our parameter of interest is gamma, which is the percentage change in wages from 1 additional year of schooling. And who can remember the formula that we used to compute gamma using ordinary squares? But let's call this one maybe y I.
Covariance yi over si over variance si.
Exactly. So gamma hat OLS, which is the way that we estimated using ordinary squares, is just the covariance of yi si divided by covariance si. Right? And just to give you a sense of where we're going, and so we're just recapping what we've done, and then we're going to build towards how we compute heterogeneity in returns to education. Okay. Now, what were some of the problems that we said we had with this Mincer equation? What were some of the issues with interpreting the gammas?
Covariance between ability and schooling.
That's right, the covariance between unobserved ability and schooling may be what?
Bias.
It might be non-zero, right?
Yeah.
Because we don't observe, so the people that go to school could be very different. Because what this is essentially saying is this gamma is going to be estimated off of, like, what's the difference between somebody, you have a population of people, let's do a very simple example. Some of those folks have gone to school for 1 year, some have not gone to any school. And we just look at the difference in the wages between those two. Right, at a very high level that that's what's happening. But there could be something systematically different about the people that went to school versus those who didn't go to school, right? And remember what we said about signaling? Schooling could be a signaling. Schooling could signal in the following way. If it turns out that the people who go to school, for them going to school is just easier because they're higher ability people, then some of this return to schooling could be capturing the fact that they're also higher ability. What was the solution that we came up with, or at least the proposal that we came up with for trying to get around this issue? What kinds of variables did we use to?
Variables.
Right. We used instrumental variables, which are variables that are going to be correlated with the years of schooling, but uncorrelated with this unobserved ability. And so the idea is that this instrument is going to influence the probability that you get an additional year of schooling, but it's going to be uncorrelated with your unobserved ability. Is everyone following me so far? Okay. So, one of the challenges with OLS is that years of schooling could be correlated with unobserved ability. That would lead to a biased estimate of learning. And we just said that the solution is the following. So we propose an instrumental variable CI. And CI has to satisfy two properties. So the first is relevance. We propose an instrumental variable that satisfies the following two conditions. And the first one is the relevance condition. And who can tell me what the relevance condition is?
The instrumental variable needs to be correlated with schooling.
Exactly. So the first one is relevance, which is that the covariance of SI and CI should not be equal to 0. Right? And the second condition is the exclusion restriction. Okay? Which is what? It's the exclusion restriction. That's the second property that the instrumental variable has to satisfy.
It's not correlated with observability.
Exactly. So the covariance of the I and epsilon I should be equal to 0. Everyone tracking with me so far? I'll just give you a moment to write that down. Okay. So this just gets us up to speed with where we are. So now, there are a couple of challenges with what we have done so far, right? So here what we're going to be doing with this mid-to wage equation is we're lumping in people who have gone to very different types of schools. And so it could very well be that there's a difference in the returns of schooling for a private school versus a public school. There could be a difference between an elite school versus a non-elite school, right? So for example, if you're thinking about, and so we want to think about how do we get around this issue? So that's the first issue. The second issue has to do with the comparison. So ideally, if I want to see what's the returns to schooling, what I want to do is I want to say, okay, Tom, I want to see what your earnings are if you get a year of schooling. And I also want to see for Tom, what's his earnings if he did not get that year of schooling, and look at the difference between those two things, right? And so, in reality, we only observe one of those things. So for example, if Tom did go to school, we observe Tom's wages conditional on him going to school. What we don't observe is Tom's wages in the case where he did not go to school. That's called the counterfactual, right? The counterfactual. So like the fact is that Tom did go to school, the counterfactual is what would have happened if he had not gone to school, right? And in this Mincer earnings function here, effectively what we're doing is we're saying, look, a person goes to school, and the counterfactual for that person, the counterfactual earnings for that person going to school is actually the earnings of somebody else who didn't go to school. But those are two different people, which is why we had this ability bias here, right? And we had to do the instrumental variables and so on and so forth. And so that's the second challenge that we have to overcome. We're going to talk about what are some ways to overcome it. And what the paper that you read captures is it says, well, what are some ways to figure out who are very similar types of people? And so to answer Mike's question, if you observe two sets of people and they're applying to the same types of schools, but they end up going to different schools, we take the fact that they're applying to the same schools and getting into the same schools as giving us some signal of their unobservability. We're saying that those two people are more similar. And so in a sense, they could be like the person who goes to the elite school could be a counterfactual for the person who did not go to the elite school. So it's not a perfect control because we don't observe the same person, but we observe the same types of people. And so that's kind of like the idea behind that. And we're going to push forth and like kind of talk a little bit about that particular learning strategy. So for those of you in the back, can you see all the way down to here? Can anyone not see here? All right. So two remaining challenges. And I'm just going to write up what we just said. So the two remaining challenges. With estimating. So the first one is that the returns to education may depend on the type of school that one attends. For example, public or private. You could also have flagship or non-flagship. So this is just for state schools. So for example, in the University of North Carolina, the flagship campus is going to be the University of North Carolina, Chapel Hill. And so there could be some differential benefit to going to UNC Chapel Hill versus UNC Wilmington, for example. Additionally, we could have within private schools, you have unpublic, elite versus non-elite. So you can think about this flagship versus non-flagship as being like a comparison between elite and non-elite within the public university context. But we can think too, like within the context of private universities, there could be a difference between schools that are perceived as being elite versus schools that are perceived as being non-elite. So what might be an example of an elite private school, private university? Others.
Duke.
Others.
University of Chicago.
University of Chicago. What would be some examples of private universities that are not elite? Or not perceived to be elite? Okay, perfect. Others?
Harvard.
Okay, Wofford. Right, and so you get the point, right? So like, depending on, so like, there could be a difference between going to a private school versus a public school, and a difference between going to elite private versus a non-elite private. What's the flagship university or the flagship campus in South Carolina? Okay. And that's interesting because we're also a state university too, so I wonder if we feel something about that. Okay, so this is the first one. The second challenge is, determining the correct counterfactual. So let me break this down. Determining the correct counterfactual. So ideally, we want to observe wages for the same individual in the case where he or she goes to college